So if we set up our matrix, we have negative 1, 4 equals 0, 2, negative 4 equals 6. Now the order that you do this really matters, because otherwise you'll end up undoing your work first. So we do one column at a time. In that column, first you have to get your 1, then you get your 0. So I need this to be a 1. How would I get that to be a 1? So we're replacing row 1. So row 1 equals. Yep. So there's 2 options there. You could either say row 1 plus row 2, or negative 1 times row 1. And both will get us there. So that's the other thing you have to realize. As we go through this, we're going to see there's a lot of different options for how to get there. So you may be solving it, and someone sitting next to you might be solving it, and your matrices could look totally different the entire time, but when you get to the end, you'll get the same solution. So you can't necessarily just check with a partner on these. So if I did negative 1 times row 1, that's the first option I heard. If you went ahead and added them, that's fine, you can do that. So then that would give me a 1, negative 4 equals 0. This did not change row 2. Next step, what do we have to do? You need to make this a 0. You have to finish column 1 before you move to column 2. We got the 1 in column 1, now we need this to be a 0. So we're changing row 2. So I just always think, if I start with row 2, it is a positive 2, so we have to subtract 2, but you can't just subtract a number, so it has to be 2 times row 1. You're doing elimination. You would take this row times a negative 2 and add them together. So that's what we're doing there. Alright. Matthew, you can use decimals. Just make sure you don't have anything else. So, if we do this, first row doesn't change. Second one, so 2 minus 2 times 1, so 2 minus 2 is 0. Negative 4 minus 2 times negative 4, so negative 4 plus 8, positive 4. 6 minus 2 times 0, so 6 minus 0 is 6. So column 1 is done. Now we need column 2. First thing is to get a 1 in column 2, so it has to be row 2, column 2. What is the easiest way to get that to be a 1? So row 2 equals, you could say divided by 4 or 1/4 times row 2, just multiply by the reciprocal. Either way, it's the same. So first row didn't change. Second, 4 times 1/4 is 1. 6 times 1/4, so 6 over 4 is 3 over 2. Keep it in fraction, not decimal. Doesn't matter so much here because it is a nice decimal, but you definitely don't want to start rounding. It will throw off everything. So if I look here, we have the 1. Now we need to finish column 2. So we need this to be a 0. So which row am I changing? So row 1 equals, if I start with row 1, it is a negative 4, so we would have to add 4, but you can't just add a number, so it has to be 4 times root. So this row stays the same. 1 plus 4 times 0, so 1 plus 0 is still 1. Negative 4 plus 4 times 1, so negative 4 plus 4 times 3 halves. So 0 plus 6, 6. And now we're done. The first equation is, and the second one, so then we just write it as 4 here. Woohoo! Is that one okay? Why don't you guys see if you can solve this one? So the first row is 1, 1 equals 2. Second, 2, 2 equals 5. First thing we need is a 1 in row 1, column 1. And we have it. So the next thing is to get this to be a 0. How did you guys get that to be a 0? Row 2. So we start with row 2. It's a positive 2, so you have to subtract 2 times row 1. Okay, this is where I'm seeing mistakes. So it might help to write out your work. We're not changing row 1. So row 2 is a 2 minus 2 times the number in row 1. So you get 2 minus 2, which is 0. Next one was a 2 minus 2 times the number in row 1. 2 minus 2 is also 0. Last one, 5 minus 2 times the number in row 1. So 5 minus 4 is 1. What does that bottom row say? 0 equals 1. And we know that is not the case, so we get to stop and say no solution, inconsistent. So I saw a lot of problems when you got that to be a 0, not carrying that same method through on all the entries. Okay, so every single number we get doing the same thing there. All right. Why don't you guys try this one? I'm struggling, I think. And that's okay, that's why we're taking this one slow. There are at least 3 options for getting the 1 in row 1, column 1. And I saw 2 of those walking around. The option that always works is to do what? Multiply by the reciprocal or divide by that coefficient. Same thing. So most of you did row 1 equals, the reciprocal 3 is 1/3 row 1. So just take it times a third. That works. I saw also, could you take the second row times the -2 and then add them together? Because 3 plus -2 is 1. So that also works. The third one, I don't think anyone realized, but it might have been the easiest. Remember, what's the third legal row operation from yesterday? You can multiply by something, you can add multiples to rows. What's the other thing we can do? We can add them, but we can add multiples of rows. But we can swap rows. Could I have just flipped those 2 rows since this one had a 1 here? If you do that, how you would write it is just like row 1 equals row 2. And you would just flip those 2 rows. So that is a legal thing as well. I didn't see anyone do that route. So the most popular one for you guys was just the thing that always works, multiplying by the reciprocal. It might create some fractions, but if you want a method that will never fail, you can do that. So every time we need a 1, multiply by the reciprocal. So 3 times 1/3 is 1. Negative 2 times 1/3 is negative 2/3. 2 times 1/3 is positive 2/3. And we did not change row 2. Alright, we work one column at a time. We got the 1 in our column. Next we have to get the 0 in our column. How can I get this to be a 0? Start with row 2. It's a positive 1, so we just need to subtract 1. But you can't just subtract a number, it has to be a multiple of another row. So 1 times row 1, or just row 2 minus row 1. Alright, so anytime you're trying to get a 0, you are adding and subtracting multiples of rows. So row 1 didn't change. Still seeing some problems with the calculation here. So write it out if you need to. I've been writing it out piece by piece. You could also say, okay, row 2, that was 1, 2, 6. Negative 1 times row 1 would be negative 1, positive 2/3, negative 2/3. So if I put those together, 1 plus negative 1 is 0. 2 plus 2/3. So 2 is like 6/3 plus 2/3 is 8/3. 6 plus negative 2/3. So 6 is like 18/3 minus 2/3 would be 16/3. Do you like it better when I show my work like this, or when I do it like the row 2 minus 1 times the number in row 1? This, or when I show each individual number? Okay. Now, column 1 is done, so we move to column 2. What do you have to get in your column first, the 1 or the 0? The 1. Row 2, column 2, has to be a 1. So we are changing row 2. What is the way to get a 1 that will never fail? So reciprocal of 8/3 is 3/8. 2 1, and 2/3, positive 2/3. 0 times 3/8 is still 0. 8/3 times 3/8 is 1. 16/3 times 3/8 is 2. Final step. We have to finish column 2. We need this to be 0. So if you want to get a 0, you can start the same way every time. So row 1 equals row 1. It's a negative 2/3, so we have to add 2/3 of row 2. So row 1 is a 1 plus 2/3 times the number in row 2. So that's still a 1. Negative 2/3 plus 2/3 times the number in row 2. So negative 2/3 plus 2/3 is 0. Right. Next one, positive 2/3 plus 2/3 times 2. So 2/3 plus 4/3 is 6/3, which is 2. So our answer I know we're still struggling a bit. Are there questions on this one? Let's do. Go ahead and do one more with 2 variables. What would you do first? We need the 1 first. Easiest option. Not the only option, but the thing that never fails. If you want a 1, you just multiply by the reciprocal. So 1/2 row 1. So give me 1, -3/2, -7/2.
I have a question. So, could you do that where like you could do like row 1 is equal to row 1 minus parentheses row 2 minus whatever, well, like plus minus whatever, something like that.
You couldn't just add a number, but you could say like -2 times row 1 plus row 2. And that would work. If you took the first 1 times -2, it would be a -4 plus the 5 to get you a 1. Alright. Next step, we need this to be 0. So -5, but you can't just subtract a number. So you always take it times the row that has a 1 in that position. So -5 times row 1. So row 2 is a 5. -5 times 1. So 5 minus 5 is 0. 4. -5 times -3/2. Equals 2 plus 15 over 2. 23 over 2. You can use calculator to get stuck on something. Next one's 17 minus 5 times -7/2. 34 over 2 plus 35 over 2. So next thing we need is for, yes, this number has to be a 1. So all you do is multiply by the reciprocal. So row 2 equals 2 over 23 times row 2. So you, same sign, you just flip the fraction. So row 1 stays the same. So row 2, you are multiplying by the reciprocal. So 0 times 2 over 23 is still 0. 23 over 2 times 2 over 23 is 1. 69 over 2 times 2 over 23 is 3. Row 1, we have to add 3/2 of row 2. Yes. So 1 plus 3/2 times 0 is still 1. -3/2 plus 3/2 times 1. So -3/2 plus 3/2 is 0. -7/2 plus 3/2 times 3. So -7 over 2 plus 9 over 2 is 1. So x is 1, y is 3. Is that okay? Alright, let's, okay, I'm I'm going to go ahead and do this one. It'll probably be my last example for the day. What do you notice about this one? It has 3 variables. How many equations? 2. So what does that tell us if we have more variables than equations? Yeah, we're going to have infinite solutions here. I have more variables than equations. I'm not going to be able to get just a number answer on this. And so let's kind of talk about how this is done with our system, or with our matrices. Okay, let's say I told you, usually I tell you what variable to keep it in terms of, right? So if I said solve with z arbitrary. So we know our answer is going to be x, y, z. Z is going to be the variable that I keep. So I need to basically solve for an x and a y.
Flip through
Yeah, I would do that. We said row 1 equals row 2. And just flip them. Then we already have our 1 in row 1 column. Next is to get the 0 underneath. So we have to change row 2. So start with row 2. It is a positive 2, so we need to subtract 2 times row 1. So 2 minus 2 times 1. Give us C. Negative 5 minus 2 times negative 2. So it's negative 5 plus 4, which is negative 1. 3 minus 2 times negative 2. So 3 plus 4, 7. 1 minus 2 times 8. So 1 minus 16, negative 15. Alright. So I got my first column done. Second column, what do I need to do? So 0 times negative 1 is 0. Negative 1 times negative 1 is positive. 7 times negative 1 is negative 7. 15 times negative 1 is positive 15. Okay, we're still working in the second column. We got our 1. Now I need this to be a 0. Two of row 2. So row 1, 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1 is 0. Negative 2 plus 2 times negative 7 is negative 16. And 8 plus 2 times 15 is 38. Okay. Then we would move to column 3, but do we have a row 3, column 3? No, so we can't finish. So my equation, I have x minus 16z equals 38, and y minus 7z equals 15. So that means x is 16z plus 38. Y is 7z plus 15. So we solved for x and y, we just weren't able to get to numbers. So my solution in terms of z would look like this. Alright. Yesterday, I posted the 7.3 day 1 handout. You should be able to finish that now. Today I posted a day 2 handout. We are combining these for one assignment. It is all going to be due on Friday, so tomorrow we're going to work some more. Tomorrow we are going to do systems with 3 equations in them. So I think the day 2 handout has 4 questions on it. You can probably do the first 2. I would not try the last 2 yet. Alright, so you can finish day 1, do the first couple on day 2.